What a conference, really. I'm usually chill about coming up on stage and like, no worries. I've done it so many times. But those talks were so good. Like I'm not sure I can fill that. I can level up that way. So I am very, very nervous. But yeah, let's talk about JavaScript and getting back to our roots and simplifying things. And so I'll talk about towards a simpler JavaScript ecosystem. Please stop the timer.
Woohoo! All right, so
Okay.
while we are waiting for the slides to...
I do want to say something, as long as
Never mind.
First of all, she's American. I did want to kill myself when the IA comes, because I am a developer, and if I don't write code, what else is there to do? Well, besides taking up knitting, but I have a better answer. When the AI comes and starts coding, I will continue coding. I am a craftsman, and I will continue coding as a craftsperson until I die, because that is what I do. And the fact that there's a factory churning out chairs, like in an industrial way, will not mean that I can't make my own handmade, beautiful, handcrafted, human-built chairs. So that is what I'm going to do. And I will write those chairs in JavaScript. So, let's talk about the simple past. And I am probably one of the oldest people in the room. I'm 54, 35 years of experience. So when I say the past, I'm talking about 95, 98, like JSHeroes, if you remember. Remember the good old days? We had one HTML file. CSS wasn't there yet, but let's say, and one JavaScript file. And what we did was just write the code in Notepad, press F5, no Macs back then, press F5, and it works, right? Or not. But if it doesn't, we edit again and press F5. Now, this is Create React App. These are the dev dependencies of Create React App. If you do an eject, then you get the whole ugly stuff. And it's not only that, there's configuration. There are 1,355 lines of configuration just to show a hello world. I mean, that is insane. How did we get from a world without tooling, just Notepad and a browser, to a world with such complex tooling, so many dev dependencies, so many lines of code? How did we get there? Is it, there was a talk about complexity. Is it inherent complexity, or is it accidental complexity? Can it be avoided? I believe so, obviously, otherwise I wouldn't be here. So, towards a simpler JavaScript ecosystem. Hi, I'm Gil, as I said. I'm really old. As I said, I will die a developer, even if AI takes my job. I'm currently a principal software engineer at Microsoft, and I work on something completely unrelated to JavaScript, unfortunately. I am here on my own personal vacation time, so not affiliated with Microsoft. One small important distinction, when I'm talking about no tooling, I'm not talking about vanilla. I love web frameworks. I love React, Angular, Vue, whatever. That is not what I'm going to talk about. I'm going to show, in this case, how I can work with React, but no tooling whatsoever. So that is very important. So why is tooling so complex today? And it's there for a reason, or at least it was there for a reason. I'll show that those reasons mostly don't exist today. And we will outline those reasons, see that the solutions we came up with, which we had to come up with, have problems, and then see how we can remove those and get back to our roots as a simple. So first of all, JavaScript source gets bigger. Okay, we started with like 1K JavaScript file, now we have like 1 meg, whatever. Our apps are becoming larger, our code becomes larger, and we need modules. We can't fit it in one file, so we need modules. Unfortunately, browsers don't understand modules. They don't understand ESM, they don't understand CommonJS. So what is our solution? We bundle everything into one big JavaScript file or multiple JavaScript files, doesn't matter, and serve that to the browser. Number 2, most people today write TypeScript. And why? Because code bases are becoming so large that we can't handle them only with dynamic typing. Dynamic typing is great, but for large code bases, we need those types to make it manageable. And problem number 3, our apps are much more complex today than they were back in the days. So we need frameworks like React, and React needs weird things like JSX. So we need TypeScript transpilation, something that transpiles our TypeScript to JavaScript, and we need JSX transpilation, which transpiles our JSX to React.createElement or whatever JavaScript we need there. So we need TypeScript transpilations, JavaScript JSX transpilations, and web bundlers. So the complexity is there for a reason. We put it there because we had no choice. This is good. The complexity is inherent complexity. We need all of these things, and others, by the way. We need the tooling. But there are problems with tooling. First of all, for me, the most serious one, there's a build step. This is JavaScript, come on, people. JavaScript is a dynamic language. Dynamic languages don't need build steps. You just write the code, run. But we need a build step, unfortunately, because TypeScript, because JSX, because bundles. So we get build time sometimes of tens of minutes. And we figured out solutions for that. We have build caches, incremental compilations. We now write our build tools in Rust and not in JavaScript, all kinds of stuff. But this adds to the complexity of the implementation of those tools and our configuration. And you just can't just refresh and try. That's another problem with build steps. And of course, we solved that with watch mode, incremental compilation, and all that kind of things, which adds to the complexity of configuration and implementation. Debugging becomes difficult because the source code and the result in JavaScript code is not the same. Obviously, we solved it using source maps and all kinds of weird stuff. But again, adding to the complexity of the implementation and configuration, and sometimes source maps just don't work. We all know that. We put in we put the breakpoint and it just doesn't work. And the result in the end of all these is that any project generates incomprehensible configs. Configuration is clearly impossible. Only experts understand that, and like rarely do we ourselves understand what we have in our project. I came to a project at Microsoft 3 months ago, and I can barely understand how the front end works there. The complexity of the configuration is really, really ugly. A nice example, this is the documentation of one bundler. Okay? Yeah. After a while, it becomes like, this is the documentation of just one bundler. And Rollup is not one of the more complex ones. We have others. So we've got tools that have become so complex just to deal with bundling, transpilation, and JSX. Another result we've seen is that upgrading this tooling has become a horror show. We just don't do it. Upgrading Webpack or whatever becomes a project. It's a ticket. It's okay, a week-long thing, and we just don't do it, so we stick with Webpack 3 or Webpack 4 or whatever. And I come also from backend. Backend is Node.js. Upgrading Node.js tooling is easy. You just upgrade, and basically it's done. Like once every 3-4 months, you have a little tweak to do, and that's it. Front-end is upgrading front-end tooling is a horrible thing. But do frameworks like Next.js, Remix, Create React App solve the problem? Yes, they hide away the complexity under the rug. And no, those are leaky abstractions. For example, we used Remix in a previous company. I wanted to add CSS and JS emotion, but emotion needs some kind of configuration in the bundler. Remix hides that away. forget about it. You can't do anything about that. And the same thing with I'm not denigrating the tool Playwright. If you want to use what is called component testing, you need to give the Webpack configuration that you have so that it can figure out how to bundle your front-end code. So yes, they solve it in some ways, but in essence, it's a leaky abstraction. We don't understand how our code works anymore. We don't. We write the code, it shows in the browser, we don't understand that thing between. Not just juniors, but they suffer the worst. And we've become so used to it, we don't see it anymore. It's like I'm the old fish who was asking you, how's the water? And you're telling me, what's water? Okay? So let's get rid of tooling. Let's get rid, first of all, of the most complex tool, bundlers. Can we get rid of bundlers today? And ask me like 2 years back, 1 year back, I would have said no. So let's take a Create React app and build towards a toolless future. Let's get rid of, I really took a Create React app. You can see it in the GitHub repo. There's a link at the end of the slide with a QR code if you want. I took a Create React app to do MVC, obviously, and moved it to not use bundles. So first of all, to understand how, we need to understand that browsers today support ESM. They understand import and export. You don't need bundlers, theoretically, because they understand that. But not exactly like this. What is missing is the .js at the end. Okay? Why? Because bundlers don't second-guess you. They need the full path. When they do an HTTP call, they need to see that there's a file at the end. They don't second-guess like Node.js does or like the bundlers do when they search for a file. So first of all, just convert. By the way, this still works in bundlers. This still works in Node.js, so we're backwards compatible, not a problem. We'll get to TypeScript, don't worry. So browsers only understand full paths, no guessing. Okay. What about bare specifiers? This is a bare specifier. When you say React and you're not specifying // or // what about them? What do we do? First of all, browsers don't understand that. You put this to a browser, they shout, this is a bare specifier, I don't know what to do. Because why? Because browsers don't look up node modules. You know how bundlers, they look in your node modules, find the package, and do all kinds of stuff. Browsers don't know how to do that. We could theoretically do this, like instead of importing from React, import from node modules, React index.js. But one, it's ugly. And two, if React has imports, then that won't work, because that won't work. So what do? We have something, it's pretty new, but it is supported in all browsers. It's called import maps. You specify this bare specifier is this file, this bare specifier is this file, etc., 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 and you're done. Basically, every time you npm install a new module, you have to create that import map. It's like a tiny build step, but it's not real. It's just when you add a package. So it's a new HTML feature supported on all browsers, Safari, Firefox, and Chrome, and tells the browser where to look for a module. So, well, there's an itty-bitty snag here, because today most node modules in NPM are not ESM. They're actually CommonJS, even React. So if I try that and point to node modules, the browsers won't understand me. CommonJS is the lingua franca of NPM. So what do? Well, we have an amazing tool called esm.sh. It transpiles ESM packages in NPM, CJS packages in NPM to ESM on the fly. Obviously, there's caching and everything. So what we did was, instead of importing and pointing to node modules, which we could do if the package was ESM, we point to esm.sh with the version. In the future, we won't need that. All packages will be ESM, I hope. It'll take a long time for that to happen, but there are signs that it is happening today. Note that current browser ESM is what I call false ESM, or faux modules, because it doesn't have the .js extension, so browsers won't understand it, but hopefully that will change in the future. And that's it. You just serve the files, point the import maps for bare specifiers, and you've got ESM without bundlers. A whole level of complexity. Remember roll-up.js configuration. A whole level of complexity just thrown away into the wind. So we don't need bundlers anymore. We use browser-native ESM. use import maps for bare specifiers to point to the correct way, and we use esm.sh for those CJS modules that aren't totally ESM yet. We still have two things, JSX and TypeScript. Let's start with JSX, easier. How do we do that? Because JSX is like this syntax that is not JavaScript. It transpiles to, if you don't know, if you look at the transpilation, it transpiles to lots of React.create elements, like in a large thing, very ugly. But how do we do that without transpiling? And the answer is, there are packages, HTM is one, which add a template tag specifier, I don't remember exact name, which enables us to write JSX inside the literal, and it will figure it out. It will interpret it on the fly and turn it into a lot of React.create elements. That's it. You get VS Code syntax coloring. Theoretically, one day it could support TypeScript, so you get type safety. Doesn't yet. And currently, it's doing runtime type interpretation, so you're interpreting that literal on the fly, which isn't good, but it's great for development. But it also has a Babel plugin, so that in production, it turns it into a set of React-create elements. This is almost as nice as JSX, yet doesn't need transpilation. Let's talk about TypeScript. How to remove TypeScript transpilation. First of all, this is a function. Let's take add. It's JavaScript. This is the same function with TypeScript. What's the problem with this? It needs transpilation. We do not want transpilation. So what do? There are two options. One is use JSDoc typings. JSDoc typings is where you put the parameters above the function, and TypeScript will type check that code as if you wrote it as TypeScript. It's JavaScript, but in the documentation you have full control over the types. You can even do, and no transpilation obviously, you can even do complex types and everything. It works. It understands DTS files, so it understands other packages. It's TypeScript with another syntax that does not need transpilation. I've worked in a previous company at Round Forest with JSDoc typings. It's great. If you saw, like a week ago, Rich Harris said he took all the Svelte code, the Node.js Svelte code, and transformed it from TypeScript to JSDoc typings, I think because he got fed up of TypeScript too. Well, at least translation too. So you get all the benefits of TypeScript without the drawbacks. I used it, it's wonderful. Almost all the benefits of TypeScript without the drawbacks. Why? Because it's clumsy. It's like, oh, it's nice, but it's clumsy. Although I actually like the fact that all the types are above the function, not inside. But if you want to wait like a few years, a lot, there's a proposal today. It's called the Type Annotations Proposal in TC39, which enables us to incorporate type systems like TypeScript, like Flow, like Hegel, there are others, not just TypeScript, and have the JavaScript runtime just completely ignore them. So it will ignore the TypeScript typing and run it as plain JavaScript without any need for transpilation. So hopefully in a few years, this will be valid JavaScript. You can just copy-paste TypeScript code or Flow code, and it will work. No transpilation needed. So hopefully, let's keep our fingers crossed. So given this, we have our holy grail. We finally have our holy grail. Front-end code that needs no transpilation, no bundling, TypeScript code, JSX code, being served by a web server, nothing else, without a build step, change the code, reload, and it works. Let's prove it. Demo time. Okay, big. There we go. This is the Create React app, the whole thing. This is the same thing, no tooling, after I changed the JSX and everything. Let's look at an example. There we go, okay? We use import. As you can see, I'm doing .js, and I'm rendering using HTML JSX. And let's do CD3. Oh, CD3. And npm start. npm start, look, all it does, I swear to you, just serve dot. There was no build step. You have to believe me. I could rm minus rf, the node modules and all that, but okay, let's see. Okay, it works. The to-do MVC we've come to know and love. To prove that it really works. Sorry for my, this really works. I save. And like in the good old days, I refresh, and boom. Yep. GeoCities, here I come. Okay, you can still have build steps. I'm not against, like for CSS modules, the import maps, all the other things, but they become simple. They become composable. I take my JavaScript and move it through build steps or whatever, but you don't have to. If you need to explain to juniors how this works, they understand it. If you need to do a simple app, you understand it. If you want to take your code, your front-end code, and run it in Node.js for testing, you don't need just to do all kinds of magic. You just use it as it is. Once we do not have, for the basics, we do not have transpilation, everything becomes simpler. Obviously, production is an entirely different thing. We need minification. We have to optimize that JSX. And currently, yes, we have to have bundles. We'll talk about that in a second. OK, that's for development. Can this be used in production? And the answer is absolutely, definitely a yes. And the reason I know that it's a yes, because at Round Forest, we used it in production. I'm not going to go through all the stuff we did. It's not like trivial, like, okay, let's just put it on a CDN and we're done, and we'll see in a second why. But a lot of things we did, and some of them are here, and we made it into production with browser native ESM, TypeScript transpilation, no transpilation, et cetera, et cetera. Let's talk about the elephant in the room, bundling. In production, unbundling is crazy. We have hundreds of files. Crazy. If we start HTTPing all of that, our users will be waiting forever, especially on mobile. As I said, heavy on HTTP. We have 5 answers for that. One answer is obviously bundling, but as we saw, bundling is a problem in development. But why is it a problem in production? Every deploy you're doing invalidates the user's browser. The browser cache, every deploy. And if you're doing lots and lots of deploys, then your users are suffering. Why? Because we're not bundling to bundle.js, we're bundling to a hash of that. And if we change one little file, then that hash changes, and the user has to download the whole megabyte again. That's a problem. The problem is bundles are too large. I've seen the bundle on my project at Microsoft, and it's too heavy, too big. And if I start splitting, I can do that, but it's an arcane art. Nobody really understands how to do it unless you do some minor incantations under the bed or whatever. Really. So in the end, it's the users that suffer this time. Let's look at other solutions. They're not perfect. We're not there yet, but let's look at some other solutions. First of all, this is a typical dependency tree. And if you're using ESM, first of all, it's not serial. It's parallel. So you're downloading the first JavaScript, and that has 2 imports. So it's downloading the 2 in parallel, and then the 3, et cetera, et cetera, et cetera. It's even better than this, but you get the idea. The browser is downloading them in parallel, so it's much better. And HTTP 1 doesn't help a lot. There's not a lot of parallelism, about 6 connections, and you're done. But HTTP 2, you get much better parallelism. It's still on 1 channel. HTTP 3, you get full parallelism, lots more, and I've seen it, the difference between HTTP and HTTP 3. It is significant. Loading many modules using HTTP 3 is much faster than HTTP 1 and 2. And today, most CDNs support HTTP 3, so it's not really a problem if you're using CDN. but it's still 5 steps. What if the browser knew beforehand of all the modules? And the answer is it can. Link rel equals module preload. You can specify in the header all your files, and the browser can load them and parse them, because it's module preload and not just preload, and parse them before continuing. It doesn't need to read the dependency tree and load and parse while it's working. This is great. But there's more. This is what happens when you're doing link rel equals module preload. So the browser gets /blog posts. Okay, there we go. The server returns the HTML. The browser parses the module preloads, and then it starts getting the files, and et cetera, et cetera, et cetera. This is nice. Preload as we want. But in static sites, this part between the get and the return HTML is very, very small, because you're just returning a file on the disk. It's smaller than 1 millisecond, something like that. Very, very fast. But in a dynamic page, this can be 100 milliseconds, 200 milliseconds, 1 second, 2 seconds. There's a lot of time between getting and starting to return the HTML, what was called time to first byte, if you remember in one of the talks. This time, that 2-second delay or 1 second delay could have been used to load all modules. And there we go. We have a new status in HTTP called 103 early hints. It's still in draft, still experimental, but used by Google Chrome and others, and supported by Cloudflare, actually, and it's working today. And the idea is this. The browser asks for the page, get/todos. The server returns 103 early hints. It doesn't return at 200 yet. You can return like an intermediate response, which says 103 early hints. These are the module preloads that I want. You can use it for CSS, by the way, not just JavaScript modules. Whatever you link preload, you just return it. Now, the browser can start downloading all those modules while the content is being generated. The browser starts downloading, and boom, we get the HTML while most of the modules are already downloaded. So perfect. And we get caching for free, because it's all using the browser caching mechanism. For me, it's mind-blowing. Look, it is so simple. We're using regular serving, regular JavaScript, regular HTTP, and not some kind of weird magic. So, in summary, last summary of the day, we can reach F5 refresh heaven without tooling and development today. Instead of bundlers, use native ESM, use import maps for those bare specifiers. If you have pesky CommonJS packages, use esm.sh. Bonus, your code works in Node.js, so server-side rendering just works, no need for bundling, transpilation, and whatever. Node testing you can use node test and not jest, which does some magic. Instead of TypeScript, use JSDoc typings, or wait for type annotations to get accepted. And for JSX, use native JS solutions like HTM. You can still have very simple build steps, as we saw, and absolutely in production, please minify your JavaScript and HTML and do all sorts of things for production. And we can still have simple production tooling using HTTP3, link rel module preload, and 103 early hints, and get crashing for 3. Unfortunately, we're not there yet. For production, for development, we're getting there. We're almost there. It's why it's a vision. Not a call to arms. But the vision is, let's get back to our roots. Let's get back to the roots of JavaScript as a dynamic language, which does not need compilation or transpilation. It does not need complex tooling that we do not understand and is arcane magic from our point of view. It needed that once for all the use cases that we talked about, but it doesn't need to anymore. So let's stop our addiction to tooling and move towards a simple JavaScript ecosystem. Thank you very much.